as I would like to then start, I will present and give the word to Marco, who will be presenting the Work Package 8 and the DIY platform. So, Marco.
Thank you. I need to learn how I go forward with this one, maybe?
Yes, that one.
One?
Yes.
Okay, cool. So this is the topic I would like to briefly discuss with you. This time we have no panelists here, so I will ask you for cooperation so that there will be some discussion and not just a boring presentation. You see the picture where we're coming from, University of Ljubljana. This is the main building, no lectures. My parents had lectures there, but now, unfortunately, not anymore. The first part is, as in previous presentation, on what we did in Work Package, and then a little bit beyond that in relation to how to apply this technology. Work Package 8 is on do-it-yourself approach. That was quite popular. Do-it-yourself means that you can do something on your own, even if you are not so skilled, but you look for information here and there. Previously, there was no internet in ancient times when I was young, but there were some magazines on that and so on. But honestly, this concept has lost quite a bit of appeal. I guess this is because, 50 or 60 years ago, these machines were becoming available to everyone. But now this is just something you can buy in every shop. So machinery itself is not as appealing as it was. As this do-it-yourself approach was very prevalent, it was also well used in hydropower industry. You may see here, there is even in Slovenian language, small country, 2 million. There is a book on that, how to build on your own the power plant. It's pretty advanced. And I have made a small research, and I found out that some books on do-it-yourself for hydropower were actually bestsellers. And I think this appeal is gone. As this, changed totally, then came this new methods, actually not so new anymore, which is 3D design and 3D printing and so on. And we thought maybe there is something we can do to make do-it-yourself again a bit more appealing and to draw youngsters into engineering and such things. Now let's go back to Work Package 8. So we are building devices with 3D printing and the methods and the machinery and the components that you can buy over internet that is extremely easily available, even for those who are not who don't have the technical background. So what we did is a bit, on the left, a 3D model similar to one that was shown before. Then we built with that methods, do-it-yourself, also the device that can measure velocity so that everyone can estimate the potential of the stream flowing, as I have heard, next to the farm or house. And then we modified the measuring station that was at our availability in the end, designed this machine. A similar one is located there outside. You may check for yourself. What we are doing, or what we are 3D printing right now, is this vein. This is currently being printed, and this device is being shown. Just instead of the cylinder, we are using a wing, or let's say hydrofoil. To have this available for everyone, then we decided to open a web page on GitHub platform. If you scan the code top right, you will reach this web page, which we call Data Hub. It's being slowly filled with information that we get. It's on how you 3D print. There is an example how to print this vein anemometer. Parts should be ready there to be downloaded and converted to STL. I have seen now that there are some issues. We'll correct them. Then what you have there is also some kind of assessment tool that was built together with Work Package 2, with David, who was previously explaining things here, and his group. And there is also information how to build a harvester, which you see out there also. Just this one is now, until it's fully finished, what we call it's private, so not shown to everyone. So what we will do till the end, in the last year and a half, maybe a bit less, we'll finish design of the oscillating cylinder and the wing or hydrofoil. Then we will finish the power uptake in the form of rotating electromagnetic induction generator and something more. Also to the private side of this do-it-yourself platform will come the turbine that you will see there. If you haven't seen it before, the white one with black rotating vane inside, which is meant to be put somewhere where you want the power to be harvested. This particular one was designed for 1 watt of power. It's actually not taking so much from the piping, so you don't need to supply with pumps much additional energy. It was part of one student project. Then comes the difficult part for me, which is about how this technology could be implemented. Actually, we are most of all in the project engineers, and we look at everything from engineering point of view. But those not engineers, owners, companies, they kind of say, now you engineers, especially mechanical engineers, stop playing and fix something and produce that. So our wish is to learn better how this technology, especially do-it-yourself technology, can be useful for companies, prosumers, and other stakeholders, maybe municipalities or big companies. So we would like actually to learn what is the best way how to scale this do-it-yourself approach, if possible, how to scale it to maybe bigger, smaller, whatever sizes, plus to higher TRLs. This kind of scaling also, although in terms of maturity of the design, because we want this product to be somehow available in any of those forms that you see outside, or maybe something else in addition. So to do that, we need to think of how this can be used. And that's a list just here on the top of 3 bullet points, how we think it can be used. So for sure there may be an educational point of view, so that you teach youngsters how to use machinery, that you see something moving. Then one important thing that we see in building something on its own, I mean by someone, is that the person actually doing that gets a pretty good view how difficult actually is to produce energy, and that it's not just given. I mean that something is behind that outlet, doing actual work, taking care and so on. So we believe that this can raise the what we call perception of clean energy transition in every individual, and can contribute to the clean energy transition narrative. And there are also other R&D and cooperation things among stakeholders that we can also support through HOPE, and in particular, in this case, through Work Package 8 on do-it-yourself approach. So if we go now to prosumers, prosumers are those who both use and produce electricity, and of course it may be interesting for someone who has some flow around the house or a farm to produce or contribute to the production of energy, like we are doing that, for instance, with solar panels that we put on the roof. This last one to three delineations, these are actually questions for you, especially for those outside of the project. How you think this HOPE technology could be adopted, and if there will be some feedback from your side, I would be very happy. So the questions are: do you think this can be integrated into your work? What platform or method do you think would be best to disseminate this technology further, and whether you think it's possible and how to bring that to commercial scale. So if there is some feedback from you that can be used from us, just please say, okay? Beside producers, actually, we think we could also target SMEs. Well, how to do that, it's difficult to say for me, but as engineer, we look at the drawing that is here. For instance, here below, the drawing of the harvester, which you see in slightly different form outside. So it's composed of plastic components, it's composed of aluminum, then you have some small equipment like bearings and so on, and then some parts that you manufacture on your own using 3D printer. So all these can be supported by an SME, for instance, selling pre-cut aluminum parts, or maybe selling kits of springs that support, or maybe some components needed to convert to electrical energy, like coils that we use and so on. We see this as an option how to continue. However, we see an option also to sell this as a kit. I mean, such that it will be still not assembled, but that you could order entire package so that all components will come to your place in a box, or maybe 2 boxes, and then you do some major installation on your own only. Maybe without those parts here, but otherwise everything ready, all parts there to be assembled, right? That's something we see as an opportunity, how we could arrange this do-it-yourself platform and help companies to bring that actually to people. That's of course in addition to the web page that we are using, because the web page and GitHub, of course, needs quite some additional skills and work and time to be used before such devices. That may be also done for the measurement device that actually works pretty well. It can be for instance also bought as a gift to a teenager, whatever. I mean, why not? And to attract young people into engineering, which is kindly dying discipline in the nowadays society. So in my opinion, as a father of such kids, I would say that this is not such a bad idea, to keep them away from the screens, or at least to watch the screens we want, parents, right? Okay. So that's something we could actually do, but it's not just that. I mean that this technology could be used also to pre-assemble or to build harvester for to be used not as a prosumers, but to use them, I don't know, somewhere in a channel, let's say outflow to the wastewater treatment plants. Who knows? And this should be done in a slightly different way so that it lasts long. For instance, in the way that colleagues in Brno are developing that it's made of stainless steel with high quality bearings. Obviously, their design is meant to be very durable. I mean, something you cannot expect from do-it-yourself that you print in the evening at home, right? But anyway, this is also something that can be offered to both SMEs at the end of the project or otherwise. Actually, we would like that this concept survives beyond the duration of HCO project. We would like to see that it continues as much as possible also later on. Maybe utilities, I'm just guessing here actually, can help to push SMEs to do something. For instance, for this meter that was already discussed, because I had to submit this before, I could delete this figure if I would have access to the file, because it was already discussed. But anyway, now it's here, and maybe the device that you can see outside, the white one with black runner, can be used just in front of this one to supply power for continuous operation of this device. As I said, at velocity 1 meter per second is designed to provide 1 watt of power continuously. Those who have background on turbine machinery will understand why it's taking so little energy out of the network, and how this is then can be seen in the blades. However, there are not just our group that can design such things. There are very capable guys in Padova, Brno, Vienna, or Barcelona who have a lot of background of design of turbine machinery and could help in this case, or Ankara, and maybe somewhere else. So maybe utilities could be used to push companies to provide something, to provide them use cases and so on. And I'm also wondering whether municipalities could be engaged. Yes, I think that's the last thing I wanted to discuss. I'm counting now on your feedback, especially those not coming from the consortium, or if those are not present, maybe from companies and municipalities from within this consortium. Stephen, will you help me? Stephen, oh, perfect. No. Stephen, you have a question.
I have a question.
Oh, okay. Do you want the microphone?
Pavel from Technical University of Brno.
Do I need the microphone?
I have no idea. Can you speak that?
I think
so.
there
better to have it.
Yeah.
Some people are online.
Yes.
Okay, thank you, Marco. I think the idea with the kit is not bad at all, because at our university there are two groups, one of them producing kits for chemistry for children, and the other, I think, some electronics, some components that children can play with and put together some circuits and so on. So why not to put together a turbine? Not a turbine, but
Harvester.
harvester.
Yeah, cool.
So why not? What I did not understand is, what is the business model of the contacting of the SMEs? So is it like the SME will go to the GitHub and for free will take the plans and sell it, or?
I also don't know, because that's not my field. I was just guessing, Pavel, sorry.
It could be your field.
But,
If you set up a startup company, it's your field.
If I could.
Or
if I
Tadej.
could, but I'm just a professor. I studied physics, you know. These two things don't go together with companies. Yeah, we were thinking about that. Obviously, this GitHub page should be there, because we promised that in the description of work that we submitted to European Union. So no doubts about that, and this will be comprehensive so that everybody can do it. But maybe for someone it's difficult to assemble. It's easy to assemble things, but maybe to find and buy them over the internet is not so easy. You know? So that's how I see a business case. Like we had, at least in Slovenia many years ago, we had a company called Young Technician, and from the name probably you get the idea what this shop was selling. Such kits actually, and also the one that you mentioned was already there. Was also there about electronics. So something that you assemble on your own, and the kids play and so on, and the like, you know. So maybe just a company selling this supports from aluminium parts. How it's called? Well known. Forgot the name. I mean, that could be their way of doing things. However, companies, SMEs could go even further, and we could design for them also some more
I think
capable designs,
more advanced solutions,
advanced solutions,
which will not be disclosed, which will not be open to the public.
That will not be open. Yes, that will not be open. For instance, the one that you shown to us with those mechanism, how it's called, H or
parallelogram.
Parallelogram, yeah, that one is very promising. However, that would be even more difficult to implement as do it yourself, and that's for sure an option.
Yeah, because as I know it from our university, as I mentioned, this chemistry and electronics, these are startup companies which are run by PhD students. And they really, especially before the Christmas, they prepare those kits and they sell it in hundreds, especially for the chemistry. I think they sold out.
Sold out, cool. Yeah, nice. I mean, there will for sure be parents that would buy that to their kids, no doubts. If that could be packed in some appealing package, you know, for sure that could find the market.
And I think to have it on two levels, I think this would be really wise to have this level of DIY and that to have this level of, let's say, more advanced concept, which then could be somehow transferred to the companies for money or to find some business model of that.
Fully agree. Thank you for pointing that out. I had this in mind a bit, but not as developed as you did. So thank you for saying that.
Thank you.
Any other questions for Marco? Comments?
You had a comment.
I have a comment, yes, actually, but this is more on the discussion that I was having with Marco about the DIY platform, and we went through this, let's say, brainstorming process of how we exploit a bit also some of the results of the HO project in a more sort of accessible way. Obviously, the first port of call for any kind of DIY sort of platform is on an educational level. So obviously, you can do this on a quite an interesting educational platform for a lot of DIY platforms out there. There are a lot of associations that work on DIY. The second thing we were discussing with Marco is that, of course, the DIY in itself is one way of helping the development of prototypes of the H-Hope harvester and actually developing something that could be sort of implemented at a sort of testing stage. So the DIY is a way of obviously producing it at a lower cost, but maybe as a way to eventually use this for the different types of commercial applications, but at a sort of a cheaper level. And the other thing that we were discussing as well was trying to see whether or not there could be commercial players there that could be interested, or even other entities, utility companies that would like to pilot it at within their own municipality and to try it that way. So I think there needs to be a bit sort of a way of understanding the exploitation potential, but at the same time protecting the IP that we have, because that's the most important thing from the project. So there's a lot of education involved, but maybe, as Pavel was saying, there could also be other commercial opportunities within the DIY platform. So,
sure. I would also like to point out that this particular design is such that it includes quite some disciplines of engineering, because you work with a plastic part. This is a bit of chemistry, not so much. However, you have quite some mechanical engineering related work, and then electrical engineering for the design of the generator, and also if you decide to go with that measurement device, there's lots of electronics inside. This actually Arduino microprocessor. You learn how to upload the code. You learn how to connect, charge, solder wires, things like that. This is all for an engineer needed to be what I call as a teacher, real complete engineer. That's directly translated from my language, but I guess you get the point, that you don't focus just on one single aspect of numerical design, but you have the broader figure that you need when you discuss with other disciplines, when you want to position your work into the engineering field and so on.
Marco, we are thinking in parallel. Exactly. I think this is one nice option how to promote these STEM disciplines. And I think every school should have it. Yeah, harvester to every school. Yeah, because this would be really a nice project, hands-on work. Where you can couple all the disciplines that you mentioned. Like learning electromagnetism, learning fluid mechanics, learning programming, everything.
Yeah, things like that. All good stuff, I would say. Yeah, thank you, Pavel, again.
And there are a lot of organizations throughout Europe working on the STEM promoting. So maybe this could also be an option for us to get into connection with them and offer that as a possibility.
I mean, your comments are, at least for me, have striking similarity with the first presentation, where we actually realize how underfunded is utilities work and water supply. This is terrible. I mean, we are just relying on what our ancestors did, more or less. And the reason for that, I see in this continuously decreasing presence of engineering in everyday's life. That social sciences and that everything is such abundancy is really destroying our engineering science.
Yes, that's what we're going to do. So a round of applause in the meantime for Marco.